Hello my viewers, welcome once again to my channel, Israeli Math Concept. In this tutorial, I'm going to take you basically on the measures of central tendency. Remember that in statistics, it's either we are trying to study the center point or location of a group of data or a set of data, or we are trying to study how individual data vary from a group of data or from a set of data. So whenever we are trying to consider the center location of a group of data or set of data, we are considering a part of statistics called measures of central tendency. In other hand, whenever we are trying to study the variability or dispersion of individual data from a group of data or from a set of data, we refer to that part of statistics as measure of dispersion or measure of variability. In this video, I'm going to consider only the measure of central tendency, but I'm not going to cover everything about the measures of central tendency. Basically, we have three important major measures of central tendency. Number one is the mean, the second one is the median, while the third one is the mode. But in this video, I'm not going to cover the three major measures of central tendency which I've mentioned, but I'm going to consider only one part of it, which is the mean. And in my subsequent video, I'm going to be uploading videos that pertains to mean, median, and mode. So do well to subscribe to my YouTube channel and as well to hit the notification bell so that whenever I drop a new math content, you will be notified. Let's get into detail. I'm beginning with the mean. Either you call it mean or you call it arithmetic mean. So what is arithmetic mean by definition? Very simple. Remember that arithmetic mean is one of the important measure of central tendency that helps us to find the center location of a group of data or a set of data. That is basically what we call mean or arithmetic mean. And in arithmetic mean calculation, or whenever we are trying to compute data for arithmetic mean, remember that it is in two ways. There is an arithmetic mean that relates to a grouped data, and also there is an arithmetic mean that relates to an ungrouped data. When I talk about group data, I'm referring to data that have something like class interval. And when you have class interval in a given data, it will help you to classify those data in group. So that is what we call group data. So there is a different formula for calculating the mean for a group data. But in today's video, I'm going to teach you only a formula for calculating the mean of an ungrouped data, because an ungrouped data is a kind of data that does not have the class interval input. So I want to put down the formula for calculating the mean for ungrouped data. Remember that ungrouped data is a kind of data or type of data that does not involve class interval. Alright, the formula for arithmetic mean or simply mean for ungrouped data is given as the mean, which we do refer as bar x. So if you call it mean, you can still call it in brief as bar x, and bar x, which is the mean, is equal to sigma x all over n. Let me first of all explain the parameters in this given formula. The first parameter we have here is the sigma. The sigma, this is sigma, and sigma is a Greek word that in mathematics we usually use it to denote the summation of a given number or variable. So this sigma will be serving us the purpose of summation whenever we are talking about a concept of statistics. Then the x in quotes implies the individual data in a set of data. In a set of data. That is the meaning of the x, the individual data in a set of data. Then the n simply mean the number of data in a given set of data. In a given set of data. That is the meaning of the n, the number of data in a given set of data. If we have something like 2, 3, 4, and these are data, automatically, if I want to know my n is how many are these data? 1, 2, 3. So that is basically the meaning of n. but the x in quotes is just the individual data itself, while the sigma, which I told you prior that is a Greek word that we use in statistics to represent the summation or to denote the summation of a given data or value. So the sigma in quote means to sum everything about this data if I'm referring these numbers as my data. Remember, sometimes you may not hear the term mean, but rather you hear the term average. They are still the same thing. Whether you call it mean or you call it average, they will still serve the same purpose. All right, let's read out the first example we have here and solve it practically so that you see how you compute for your arithmetic mean whenever you are given a question to solve. The first example we have here says, find the mean of the following set of number 4, 7, 3, 6 and 0. So how do we find the mean of this given set of number? It is very simple to do so. Looking at this set of number, it is an ungrouped data because there is no class interval for it. And because there is no class interval given for it, automatically it is an ungrouped data. And the formula for mean for ungrouped data is stated already on the board as mean by x equal to summation of x all over n. Remember, this is sigma, and sigma means summation. So that is summation of x all over n. And this n is the number of data in a given set of data. If you don't consider it that way, you can still call this n the frequency of the data. They are still the same thing. Okay, this implies that since we stated the formula already, summation of x, remember that x is the individual numbers we have here. So summation of x means to sum the individual numbers we have here. So let's now sum the x. That is summing the individual numbers here. We then have that 4 plus 7 plus 3 plus 6 and plus 0. That is the meaning of summation of x, to sum the individual numbers we have. Then all over, remember our n is the number of data we are given. Let's calculate how many number of data we have. The first one, second one, third one, fourth and fifth. So we have 5 data that we are given. So that is the implication of this n. If you don't want to consider it that way, remember I said prior that this n is the same thing as your frequency. So you can still say how many 4 do we have here? You just have 1 4. How many 7 do we have here? Plus 1 7. How many 3 do we have here? Plus 1 3. How many 6 do we have? We just have 1 6. And how many 0 do we have? We just have 1 0. Such that we now calculate 1 plus 1 is 2, plus 1 3, plus 1 4, and plus 1 5, which is the same thing as this. So remember that our n is how many numbers we have here. If you don't consider it that way, you can still consider n as your frequency. They are still the same thing. So let's calculate further. 4 plus 7 will give us 11. And 11 plus 3 will give us 14. And 14 plus 6 will give us 20. 20 plus 0 is still 20. So we have 20 all over 5. So automatically 20 divided by 5 will give us 4. So automatically our bar x, which is our arithmetic mean, is equal to 4. This is basically how to calculate your arithmetic mean. First thing first, state your formula, after which you impute the various variables you are given, compute the variables and get to your answer, full stop. Let's solve the second example also. The second example says, the average of x, 3, x minus 1, 5 and 2x minus 2 is 5. Then we are asked to find the value of x. Actually, this second question, I sourced it from NECO 2002 question, and that is question number 17. So this example is sourced from NECO 2002 and exactly question 17. Then to find the value of our x, first thing first, we state the formula for our mean, which is the same thing as average. And that is our average, which is equal to summation of x all over our n. This is the formula. Remember that mean can still be considered as average. And now from the question we were told that the average of all this set of number is 5. So wherever we see average, we can substitute it for 5. Very simple. And that is equal to, remember 5 is equal to, summation of x means summing these individual values of this set of data. So the first value we have is x, then plus, the next value is 3, plus, the next one is x minus 1, in bracket close, the next one is 5, then the next one we have is 2x minus 2, in bracket 2x minus 2. So what I did basically was to substitute 5 for the average because we were told that the average is 5. So I substituted for the average as 5. And that is equal to summation of our x. And our x are the individual values of this set of data, which I've summed already. And that is all over our n. Our n is how many times does this number occur. That is the frequency. If you don't consider it that way, you can just count the number by saying the first one is 1, 2, 3, 4, and 5. So we have just 5 numbers. Hence, we then have that 5 is equal to, let's open up the bracket. We have x plus 3 plus x minus 1 plus 5 plus 2x minus 2. Remember, to open a bracket of this form is just like using 1 to multiply out this bracket. And when 1 multiplies out everything in this bracket, it will still give us everything in this bracket. So whenever you have an empty bracket that does not have a number that is multiplying it directly, to open up a kind of bracket of this form is very simple. Assume there is 1 here and use it to open up the bracket. And that is all over. We have 5. So we have that our 5, which is our average, is equal to, let's now collect the like terms. We have x plus x, which is 2x, and 2x plus 2x will give us 4x. So we have 4x. Let's add the numbers also. 3 minus 1 will give us 2, and 2 plus 5 will give us 7, and 7 minus 2 will give us 5. So we have plus 5, then that is all over. We have 5 here. So this implies that when we cross multiply, remember that 5 is the same thing as 5 over 1, because any number divided by 1 will still give you that number. So 5 is the same thing as 5 over 1. And when we cross multiply, 1 multiplied by 4x plus 5 will still be 4x plus 5. 4x plus 5. And that is equal to 5 multiplied by 5 will give us 25. 25. Okay. Then let's now make the x the subject of this given formula. We then have that 4x is equal to 25. Then positive 5 crossing over to the right hand side of the equation, we change to negative 5. Then we have that 4x is equal to 25 minus 5 will give us 20. So this implies that when we divide both sides of the equation by the coefficient of x, which is 4, we have 4x over 4 equal to 20 over 4, such that 4 will cancel out 4, and this implies that our x is equal to 20 divided by 4 will give us 5. So automatically, the value of our x, which is what we are asked to find, is equal to 5. So our x is equal to 5. This is basically how to calculate for your mean for ungrouped data. Very simple. Remember to put this formula in your heart so that whenever you are given a question as related to mean, first thing first, you state your formula, then you substitute for the parameters in your formula and get the value of your mean. And whichever way the question is put, just like the example 2 we have here, whichever way the question is put, you can still substitute for your values and find the corresponding value you are asked to find. So in this video, we basically studied one of the measure of central tendency, which is mean or arithmetic mean. So in my subsequent video, I shall be uploading video as pertaining to other measures of central tendency, which includes median and mode, and I will solve practical problems or questions as pertaining to that. Do well to stay tuned by subscribing to my YouTube channel, as well as clicking the notification bell, so that whenever I upload a new math content, you will be notified. You can as well follow me on Facebook at Israeli Online Math Concept. Remember to share this video. Thank you and see you next time. Bye bye.